Alright, this video is going to be over the mole, and it's going to be over the use of Avogadro's number, so doing mole conversions between moles, molecules, and number of atoms. Alright, so the mole, if we have 1 mole of anything, so stars, that means we have 6.02 times 10 to the 23rd stars. Okay? It can sometimes be confusing, and so we're going to work with a dozen for a little bit and then move on to moles. But before we do that, I just want to show how big this is. So 6.02, and then there's 21 more zeros. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21. So this is a very, very big number. It's much bigger than we can really interpret, because it would take you more than a lifetime to count that high. If you were counting, I think, 1,000 or 1,000,000 numbers per second, it would still take you more than a lifetime to do that. So it's huge. And it can be used. The reason we need a number so big is because we have to be able to weigh something in the lab that is a measurable quantity. If we were to try to find the mass of 1 atom, we could never grab 1 atom and put it on a scale and actually be able to find the mass of it. So, but if we have this many carbon atoms, let's say, then it would weigh 12 grams. So it would have the mass of about 12 paper clips. So you can see that there's a need for this. There's a very big need for this size of a number. So before we do these conversions, let's talk about a dozen real quick. So we all know that 1 dozen is equal to 12 things, right? So if we have a dozen stars, that means we have 12 stars. And so let's say we've got 35 cupcakes, and we want to know how many dozen that is, right? Well, we know that there would be 12 cupcakes in 1 dozen. And so I put cupcakes on the bottom so that it could cancel out on the top here. And we end up with dozen on top, which is what we wanted. And then I'm going to take 35 and divide by 12, and that gives me 2.92. All right, so let's try another one. Let's say that I have, let's say that I have 506 dozen. And I want to know how many cupcakes that is. So again, we're going to have 1 dozen, and this time I'm going to put dozen on the bottom so that it can cancel out with dozen on the top. And we know that 1 dozen is equal to 12 cupcakes. So dozen cancels out, and we're left with the number of cupcakes. So it's going to be 506 times 12. So that's 6,072 cupcakes. All right. Okay, let's try something different. All right, so let's say we have 34.5 dozen toy cars. All right, so we have 34.5 dozen toy cars. And we want to know how many cars that is. So the first question is, how many cars? And the next question is, how many wheels? All right. And so again, I'm going to put 1 dozen on the bottom. So 1 dozen cars would have 12 cars. And so that would be 414 cars. Now the next question is, how many wheels is that? And so we know that in 414 cars, in one car, there's 4 wheels. And so if we take 414 times 4, we get 1,656 wheels. All right. And so when we go back and look at dozen, or mole, right? 1 mole of whatever you have. So if you have 1 mole of a molecule, like CO2, so if you have a mole of CO2, then that means that you have 6.02 times 10 to the 23rd CO2s. So you have that many molecules of CO2. And if you had 1 mole of, let's say, iron, the atom iron, that means that you have 6.02 times 10 to the 23rd irons. And so this would be the number of atoms here, while this would be the number of molecules, because CO2 is a molecule. And so if it asked you for atoms and you were looking at CO2, you'd have to take the number of molecules and multiply it by 3 because you have 1 carbon and 2 oxygen. All right, so let's try and look at some problems. So in this first one, we want the number of atoms. And I have 1 mole on the top. And just to remind you, we can write Avogadro's number one of 2 ways. All right, we can write it like this: 1 mole of whatever we have divided by 6.02 times 10 to the 23rd of whatever we have. Or we can write it the opposite of the inverse of that, where mole is on the bottom and Avogadro's number is on the top. All right, so let's go back to this problem here. And we have 2.36 moles of aluminum. And so I know that mole has to go on the bottom. So 1 mole of aluminum is 6.02 times 10 to the 23rd aluminum. And that's an atom, right? So we found the number of atoms by getting to aluminum. So mole cancels out, and we end up with 1.42 times 10 to the 24th aluminum atoms. Okay? All right, next we want to find the number of formula units. And just in case you've missed it or haven't quite understood, formula unit is a word kind of like molecule. It's for ionic compounds, though, because ionic compounds are not molecular, so we technically cannot call them a molecule. They're formula units. All right, so you can look at it like a molecule. All right, so we have 2.47 moles of iron 3 oxide, and we want to know the number of molecules or formula units. So 1 mole has to go on the bottom so that moles cancel out, of Fe2O3 is equal to 6.02 times 10 to the 23rd Fe2O3s. And so mole cancels out, and we're left with formula units, because that's a formula unit, right? It's an ionic compound. And so the answer that you get when you type it in the calculator is 1.49 times 10 to the 24th Fe2O3s. So if we go back to compare these, I want you to notice up here we have an atom. Whoa! And then down here we have a molecule, but they were both calculated the exact same way. And so it just depends on what you have and what you want. on how you're going to calculate them. All right. So right here we have 2.36 moles of aluminum. Moles canceled out. All right, we have 2.47 moles of iron 3 oxide. Moles canceled out here. We'd hit the exact same thing. All right, so don't overthink this. If you have moles on the top and you're looking for the number of particles, you're going to have to use Avogadro's number somewhere. All right, let's try a couple more. In this one, we want to find the number of atoms of carbon, we want to find the number of moles, and we have 1.87 times 10 to the 24 atoms of carbon. So I'm going to put, this time, this is the number of particles here. Atoms is the number of particles. And we want moles, so I know moles has to go in the top. So 1 mole of carbon is 6.02 times 10 to the 23rd atoms. And so atoms will cancel with atoms, and we'll end up with moles of carbon. So we'd take 1.87 times 10 to the 24th, and we'll divide it, because this is in the bottom, by 6.02 times 10 to the 23rd. And we end up with 3.11 moles of carbon. All right, the next problem, we have 2.49 times 10 to the 23rd molecules of SO2, and we're going to put 6.02 times 10 to the 23rd SO2s will be in 1 mole of SO2, because we want to look for moles this time. And so molecules of SO2 and molecules of SO2 cancel out, because SO2 is a molecule, right? And then I'm going to take 2.49 times 10 to the 23rd and divide it by 6.02 times 10 to the 23rd. And I end up getting 0.414. So even though both of these are different, as this one is an atom right here, let's see, this one over here is an atom, but this one down here is a molecule. They're both solved the same way, because we're just looking for the number of moles, and we're given the number of particles, and it is that particle. This is a molecule, and we're given molecules, and this is an atom, and we're given atoms. Okay, so let's try a couple more, a different type of problem. All right. This time we're given 2.69 times 10 to the 25th formula units of AlCl3, and we want to know how many moles. So I'm going to write down what's given to me, 2.69 times 10 to the 25th formula units of AlCl3. And so what that basically means is that I have this many 2.69 times 10 to the 25th AlCl3s. So I'm going to go ahead and write that instead. All right. It won't let me. Why won't it let me erase it? All right, it wouldn't let me erase it, but I was able to go back and rewrite it. Okay, so I have 2.69 times 10 to the 25th AlCl3s, and I want to know how many moles that is. Well, I know that if I had 1 mole, and mole can't go on the bottom because I want moles, and I have AlCl3s on the top over here. So I have to put the same thing down here. So I know that if I have 1 mole, it'd be 6.02 times 10 to the 23rd AlCl3s, and that would be a mole of AlCl3. So AlCl3s cancel out, and I'm left with moles. So I'm going to take 2.69 times 10 to the 25th and divide by 6.02 times 10 to the 23rd, and I end up getting 44.7 moles of AlCl3. All right, so in this next one, we want to know how many aluminum atoms there are. So I'm going to write down what's given to me. So I'm going to go back up to the top, and I've got 2.69 times 10 to the 25th AlCl3s, right? Okay, so, and I want to know how many aluminum atoms. A lot of students here, what they end up doing is they go to moles and they don't know where to go to from there because they've done it wrong. So if this is how many formula units you have, if you have one formula unit, one AlCl3 only, then you only have one aluminum. So it's that simple. It's the same number because there's one aluminum in every single aluminum chloride, and this is how many aluminum chlorides you have. So I've got 2.69 times 10 to the 25th aluminums. All right. Got a couple more here. How many chlorine atoms? I'm going to write down what's given, 2.69 times 10 to the 25th AlCl3s. And if we have one AlCl3, we want chlorine atoms. There's 3 chlorine atoms there. So AlCl3s cancel out, and so it's going to be 2.69 times 10 to the 25th times 3. And so my answer is 8.07 times 10 to the 25th. All right, now we've got one more. And so this is the same thing, only this time we're looking for total atoms, right? So you can do this one of two ways. One way is you can add together the aluminum atoms and the chlorine atoms because those are the total number of atoms in the whole thing. Or you can do it the same way we've been doing it and write down 2.69 times 10 to the 25th atoms or aluminum chlorides. One aluminum chloride is equal to 4 atoms total because there's 1 aluminum and 3 chlorines. So I'm going to take 2.69 times 10 to the 25th and multiply by 4. And I get 1.08 times 10 to the 26th atoms total. All right, so let's try one more. All right, so in this one we've got 4.37 moles of H2O. How many hydrogen atoms do we have? So I'm going to write down what's given to me. I've got 4.37 moles of H2O. And I know that if I have 1 mole of water, that does not give me hydrogen atoms. It gives me 6.02 times 10 to the 23rd H2Os. So it's just given me the number of H2Os. But in one H2O, I have 2 hydrogen atoms, and so that gets me to the number of hydrogen atoms. And so I end up getting 5.26 times 10 to the 24th hydrogen atoms. All right, so the next video will be the one about molar mass, and then I will do a video about using both of them in the same problem, but it might not be posted until late next week.